All right, so this is kind of the second half of section 1.4, and this is on significant figures. Sometimes also called significant digits. Or usually just in shorthand, excuse me, sig figs. All right. Basically, what these do is these let us keep track of how precise a number actually is. I realize that's something that we haven't covered yet. That's a section 1.6 topic. But basically, sig figs, sig figs let us know how much we can trust the given digits, or how reliable digits in a number are, or in a given value, given measurement are. So we have some rules that we use to determine them. First thing that we're going to look at is a number without a decimal place that does not end in a zero. So let's say that I have the number 153. In this number, all three of these numbers are significant. This has three sig figs, or all abbreviated 3SF. Same deal if I have 1,423. I have four sig figs on that. Now, where this gets a little bit strange, or will seem a little bit non-intuitive at first, is if I have a number that ends in a zero and does not have a decimal place in it, so 101,000, just for example. I'm going to start counting sig figs. I'm going to start at the right, but I'm not going to start counting sig figs until I get to a non-zero number. Then I'm going to keep counting from there. So these are zeros. No decimal point here. These are zeros. So I only have 1, 2, 3 sig figs. Right? Now, this changes if I put a decimal point in the center here. Right? If I put a decimal point here, first of all, everything to the right of the decimal point is going to be significant. Everything to the left of the decimal point is also significant. So 1, 2, 3, 4, 5, 6, 7. I have 7 total sig figs here. Now, I say everything to the left of the decimal point is significant. Basically, what I'm going to do is I'm going to count to the left of the decimal point till I get I guess really where I'm going with this is that if I were to stick another zero out in front of here, if I were to stick a leading zeros to the left of the decimal point are never significant. But aside from that, this is significant. If I have a decimal point, I have a zero to the left of the decimal point. I have my first number to the right of the decimal point is a non-zero number. Then I'm going to start counting left to right at the non-zero number. 1, 2, 3, 4. So this is going to be 4 sig figs. Right now, if I have a decimal point, I have a couple of zeros. I'm going to start counting. I should not start counting until I get to a non-zero number. But any zeros that I have after that are significant. So 0.00052220. This is going to have 4 sig figs. All right. So that's how we determine sig figs. Now let's look at how we handle these in calculations. Right, so we have two different sets of rules for when we are for sig figs when we are multiplying numbers and when we are multiplying or dividing numbers, I should say, and then a separate set of rules for adding and subtracting when we are multiplying numbers. So let's say that I am multiplying 101 times 92 times 0.0023. Okay. Sorry, I can't do that one in my head. I need to plug that one into the calculator. 101 times 2 times 0.0023. And my calculator is going to spit out the number of 21.3716. But can we use all of those numbers? The answer to that is no, we cannot. Now, when we are multiplying or dividing, works the same way with either, or when we mix operations, we want to go through and we want to look at how many sig figs are in everything in our calculation. So I have 3 here, I have 2 here, I have 2 here. Now, the fewest number of sig figs is going to determine how many sig figs I have in my final answer. If we look at this, I have 3, 2, and 2. So 2 is my fewest. My least precise number has 2 sig figs. So that means that I have to round my answer to 2 sig figs, right? So I'm going to look at this, 21.3, right? Now, I need to cut this off after the 21. And so I'm going to round this based on just my standard rounding rules. So this is less than 5. It's a 3, it's less than 5, so it's going to stay 21. If it's 5 or over, we round up. So that is our answer to this. Now, when I add or subtract, let's say that I'm adding 101.24, 15.632, and 0.0046. All right, let's add those up. 6, 6, 7, 8, 6, 1, 1. 116.8766. Right. When I add or subtract, I look for which has the fewest decimal places. In this case, my 101.24 only has 2 decimal places. So that's where I'm going to round off. My answer is going to be 116.8. So 87, that 7's followed by a 6, so I round up 116.88. Right. That is how we find our sig figs. Or that's how we do sig figs when we are doing calculations. All right. One last thing to cover, and this ties in really nicely with sig figs actually, but it's also in section 1.4, is scientific notation. Scientific notation is a convenient way for us to write really big or really large, or really big or really small numbers. But to illustrate it, what I'm going to do is I am going to just give a couple of fairly simple examples. So let's say that I have the number 543,000. Okay. Now, if I want to write this in scientific notation, here's what I do. I'm going to move my decimal place down to where I have a single digit to the left of the decimal place. So that's going to be, I moved it 1, 2, 3, 4, 5 places. That's going to give me 5.43. And then I'm going to say times 10 raised to the power of however many decimal places I move this. So 1, 2, 3, 4, 5. Raise 5.43 times 10 to the 5th. Now, that's for numbers larger than 1. Numbers smaller than 1, what I'm going to do, so let's say that I have 0.000424. Right, I move to the right, 1, 2, 3, 4, 5, 4.24 times 10, but now it's going to be times 10 to the negative 5th. 4.24 times 10 to the negative 5th. And that is scientific notation.